Okay, I'm going to start with a number 65 in section 4.3. And if you look at the problem, it asks you to find the indicated trig value in the specified quadrant. So for 65, it says the sine of theta is negative 3/5. Okay, so this is similar to the problems where you, like maybe back in 5, 7, 9, 11, where you had to you're going to have to draw the triangle and kind of figure some stuff out. So I am going to want to think about where it's on the quadrant in a minute. Let's go ahead and say, what is sine using SOHCAHTOA? Isn't it the opposite over the hypotenuse? Okay, so my opposite side, okay, now here's the thing with that negative. I really don't know whether it goes with the 3 or the 5 because you could write it any way you want. But here's the deal. I can almost ignore it a little bit. They did give me a little bit more information. They told me it was in quadrant 4, which if you think about that, all students take calculus. It makes sense that the sign would be negative if it's down here in this quadrant, wouldn't it? Because we know that the sign would be negative in that quadrant. So they want us to actually find, what they asked us to find was cosine of theta. Now, in that quadrant, if I use my all students take calculus, I already know my cosine value is going to be positive. One thing you can do, there's a couple of ways you can take care of all these different signs you're going to come up with when you're doing these trig functions in this section. If you can use the all students take calculus and just go, okay, cosine is going to be positive there, so I know I can kind of ignore the signs and look at the numbers. Another thing you can do is you can think about it as you're putting it on the coordinate plane, but you just got to be really careful. I would always, even if you're thinking about the signs, I would always use that all students take calculus reminder device about which trig function is positive in which quadrant. I'd use that to kind of check my work because it's just so easy to get off. So, okay, I've got this right triangle. I know it's going to go down here in quadrant 4. They told me that. And I know that here's my angle. This is called our reference angle. We know that the opposite side is 3 and the hypotenuse is 5. And the thing about it is, if you think about you would go out here with your x's, right? And you'd go down with your y. So if I want to take care of the signs while I'm doing it and not use the memory device, I would know that's down in negative 3. Now, if I just think about the numbers, I've got a right triangle, and if you remember, there's a 3, 4, 5 right triangle. And sure enough, I have a 5 on my hypotenuse, and I've got a side that's 3. Even though it's negative 3, I'm still looking at it like 3. So I can know this missing side is 4. Now, I'm almost done. I had to use the information they gave me here. I had to label it from SOHCAHTOA. And then I had to kind of draw a picture of it. It's in quadrant 4, so it kind of helped me to come and put it in the correct quadrant. So if cosine, I know from SOHCAHTOA, is adjacent over the hypotenuse. Okay? So if here's my angle, my adjacent side would be 4, and my hypotenuse would be 5. If you look at this, if you're thinking about this 4, this side that's 4, you'd be going out in the positive direction on the x-axis, so it would be a positive 4, and your hypotenuse is just always positive. So it would be 4/5. I could actually draw and figure out the triangle just from the information they gave me, but then if I want to check my answer, sure enough, cosine is positive in that quadrant. Another thing, again, you can always just use the numbers, ignore the sign, and then use the memory device to go, okay, it should be positive because cosine's positive in that quadrant. A lot of times that's what people do, just because it takes a while to draw stuff. Let's do 73 next. I'm just trying to pick some that I know look a little strange, and I know that you get home and it's like, oh, wish she'd done that one. Tangent of theta is negative 4, and we also know the cosine of theta is less than 0. That tells me the cosine is negative. Right there, I've got enough information to figure out what quadrant that I should be working in. Because if I look at the value, the tangent is negative. So let's write all students take calculus. If the tangent is negative, it would either be quadrant 2 or quadrant 4. But they give me another piece of information. They say the cosine is negative. Well, down here in quadrant 4, the cosine's positive. That's why the C is there. It's to remind us that the cosine's positive. So it must be over here in quadrant 2. My angle that I'm looking for is in quadrant 2. Now, did they ask me for the angle it says find the value and the trig identities. Use the given value and the trig identities to find the remaining trig functions. They're not asking me to tell them what the angle is here. They just want all the rest of the trig functions. So I know that, here's what I know. I know tangent theta is -4. So if I just flip that fraction to get my cotangent, it's going to be -1/4. Now, let's think about the sign. This thing, we said it was in quadrant 2, so the sign's going to be positive. So if I want to, I could just kind of go, okay, it's going to be positive if I don't want to worry about, thinking about the point on that triangle and whether I went down y or up y and all that sort of stuff. I can say I know those are going to be positive. And if I want the cosine, I know that in quadrant 2 the cosine's negative. So, one thing you can do is go ahead and write the negative out in front of the fraction. Just don't accidentally write the negative and then think about the negative while you're doing the problem and put another negative and turn it into a positive. I've seen students do that because they're thinking about both things and they're forgetting that when they put the negative there, they're like going, I'm taking care of that sign and I'm not going to worry about it when I look at my, my work. All right, so now, if you think about this, this doesn't seem like a value that would come from a 30, 60, 90 or a 45, 45, 90. How am I going to mess with this? I know that, tangent is opposite over adjacent. And I guess I could go in and let me draw a green triangle. If it's in over here and my angle's here, I could say, well, here's my right angle. Opposite over adjacent. Opposite side would be 4 and adjacent side, I could say that's opposite over adjacent. I could just stick a 1 under there because 4 over 1 is equal to 4. Now, if I want to really be careful and really think about my signs and not rely on the memory device, if this side is going 1 unit out to the left of the origin, this is actually going to be a -1, and it's going up 4, so it's still a positive 4. So what they want is for me to find the remaining trig values, okay? So if tangent theta is -4, cotangent's -1 over 4, I can find the hypotenuse now. I haven't done that yet, so let me just come over here because I know that S for sine in the memory device is over my green triangle. This is -1, this is 4. So the hypotenuse is the square root of -1 squared. I can't, let me try it down here, write a little bit bigger. -1, the whole thing squared, plus 4 squared. So that's going to be the square root of 1 plus 16. That's the square root of 17. So my hypotenuse is actually the square root of 17. I'll write it up here and just kind of draw an arrow there so we know what it is. All right, so now hypotenuse is always positive. I don't need to worry about is that negative or positive. Now I can actually solve for my trig functions. The sine of that angle is going to be the opposite. Again, I'm thinking SOHCAHTOA. I'm always kind of keeping SOHCAHTOA as a tool in the back of my mind that's going to help me. The sine is going to be the opposite over the hypotenuse, so that's going to be 4 over 5. Now, if I want the cosecant, all I got to do is flip that fraction, so it's going to be 5 over 4. Okay. Whether I used the signs of the numbers on the triangles according to where they're at on the coordinate grid, or whether I just thought about all students take calculus, the sign should be positive in that quadrant, so I'm going to leave it positive. Now the cosine is going to be adjacent over hypotenuse, so let's see. I'll use some purple here. The adjacent side is -1. Okay, I already put my negative down, so let me just write the 1. And the hypotenuse is 5, so it's -1 over 5. So if I want the secant, all I got to do is flip that. It would be -5 over 1, but that's just -5. I won't even write it as a fraction. I'll just kind of scribble over that fraction with my marker here. So I've got all my values here for 73, and I'm finished with that one. Okay, so I'm going to try to at least get us rolling on 93. Again, there's another one like this, but I'm going to spend as much time as I can afford to on this video. The time's kind of running down. So negative square, we know that the secant of the angle is -2 square root of 3 over 3. And I'll just work the A part. And again, I just know that the A part and the B part might have nothing to do with each other. So just kind of... I think they are related, but just in case it just doesn't work out, maybe you need to check the answer key, but it could be those angles have nothing to do with each other. I already know this has something to do with the 30, 60, 90. And the reason I know is I see that square root of 3 there. And I know if they're not letting me use my calculator, that's the only thing it could be. So across from the 30 degree, if we do our labels, we call that x. Across from the 60, we call it x squared root of 3. And across from the right angle, we call it 2x on the hypotenuse. So now let's think about this value for a minute. This has a radical in the top, and usually what happens is that used to be in the denominator. So this would be like a negative 2 over square root of 3 that somebody rationalized. So you almost have to undo your radicals when you see them in the numerator almost every time. So let's think about this. The secant is the opposite, or the reciprocal of cosine. Cosine is adjacent over hypotenuse. So this would be hypotenuse over adjacent if I want to think about it. And let me just write down negative 2 over square root of 3. So if I'm thinking about, where this could be on the unit circle, and I think all students take calculus, secant and cosine are reciprocals of each other. So I really, when I'm using my memory device, I'm thinking, okay, where is the cosine negative? Because it's the reciprocal of cosine. The cosine's negative here in quadrant 2 and here in quadrant 3. So it's possible, it says find two solutions of the equation. So there's two places where it's going to be negative. So when they say solve the equation or solve the equation, they're asking me, what's the missing angle? Figure out the missing angle. And guess what? We don't really want you to do use the calculator with it. And we're only talking about, the regular unit circle. We're not going to talk about going a couple of trips around the unit circle or anything weird like that. And they want our answers in degrees, and they want them in radians. So I've kind of figured out some things about this. This is hypotenuse over adjacent. So if you think about this, here's where I go figure this out. I'm looking at my triangle I drew over here, and I'm saying which angle has maybe they both have if I think about this, couldn't I cancel the x's out, and this could be like 1, and 2x divided by x would be just 2. And x squared root of 3, if I divide the x out, is square root of 3. So I can just kind of look at these basic numbers here. Which one of these has an adjacent side of square root of 3? I'm kind of looking here because a lot of stuff's going to have the hypotenuse is 2 no matter what. What angle has an adjacent side of square root of 3? Oh, it's the 30 degree one. When I drew this 30, 60, 90, my answer could have been 30 degrees or it could have been 60 degrees as far as the reference angle goes, and I didn't know which one. So I have to think about that a little bit when I see that, whatever the angle is, it's got an adjacent side of 13. So I know that I'm talking about a 30 degree angle, and it's a 30 degree angle, but it's the reference angle that I'm talking about, so it could be here or it could be here. Okay, so let's look in quadrant 2. What would that angle be? It would be 180 minus that 30 degrees would be 150 degrees. And if you change that over, that's like 5 over 6 pi if you were to convert it into radians. So that's one solution to my equation. The other one is down here in quadrant 3. It has a reference angle of 30 degrees, but you think about it, here's 180 or pi, but I'm gone 30 degrees past 180, so I got to say, oh, well, that one would be 180 plus 30 degrees. Again, we're always doing things in reference to the x-axis. So when we're over here in quadrant 2 and 3, we got to do it, we got to think about this 180 degree thing here. So it's 180 degrees plus 30 more, that's 210 degrees. And if you change that over to radians, that ends up being 7 pi over 6. To me, this has got a lot to think about in it, and part of it is when you write that secant is a hypotenuse over adjacent, you've got to think about, well, which one had an adjacent side of square root of 3. And then down here in the reference angle, you're just thinking, okay, everything is in reference to the x-axis. And I'm in quadrant 2 or 3, so we're talking about 30 degrees shy of 180 for the quadrant 2 one here. And on the quadrant 3 angle, we were thinking, well, what's 30 degrees past 180? And that's how I got my 210. These are the solutions. They're the angle that has this secant value. And again, if you think about it in that quadrant, the only thing that would be positive is tangent. So it makes sense that secant or cosine, since it's a reciprocal function, would be negative there. So it all kind of makes sense when you look at it.